Let's begin our session. So good afternoon, Sienna, Pranika, Vanshika, Prashant, Prasad, Parth. Let's start. Today we are going to see a new chapter. So is everyone excited for this chapter? It was the previous chapter that we were studying, permutations and combinations. I hope that you learned and even enjoyed that chapter. Today, another interesting chapter we are going to start, that's functions. So is everyone ready? Let me know in the chat box. Ready by Prashant. Perfect. Okay, so functions is also an interesting chapter, like permutations and combinations. Again, as I took a different approach for permutations, combinations, similarly, I'll take a bit of different approach for functions as well. This function chapter in your previous syllabus, it was not a separate chapter. It was included in sets and relations. So the chapter's name previously was sets, relations, and functions. And you had only small part or only the last exercise in sets and relations, which was related to functions. However, functions is critical to solve your calculus problems, questions that come from your limits chapters, from your derivatives chapters. For solving those questions, you'll need a base of functions chapter. If you see any IIT-JEE question of limits, each and every limits question of IIT-JEE needs knowledge of your functions chapter. Like why this graph came from, or why should we take these values? Why are these values not included in that? So that understanding can be developed from function chapter. Hence, functions has been given its due respect. A separate chapter has been given to functions. And today we are going to start with that chapter. For sets and relations, I said that sets are like alphabets of English. So if you want to write an essay in English, so you can't directly write an essay. First, you'll need to learn alphabets, then words, then you'll need to form sentences. After sentences, you'll write paragraphs, and then you'll get to a point where you can write essays. So your sets and relations are like alphabets. Until and unless you know your sets and relations very well, you can't progress into mathematics world. Because you'll need sets and relations in some or the other way in every other chapter. And functions is like words of English. So once you have that basic understanding of alphabets, you know what sets are, what relations are. Using that basic understanding, you'll get a more detailed idea and you'll understand what words, how words are formed, or how functions understand, or how functions work. And these functions are your basics for calculus. So as words are basics for sentences, if you'll understand these functions, you'll be able to get your calculus part better. So main chapters of calculus in 11-12 syllabus or JEE are, first one is your limits, then your differentiation, then your integration. If you see your 12th standard chapters, even your JEE syllabus, 12th standard chapters are, first one is differentiation, then you have application of differentiation, then you have indefinite integration, then you have definite integration, then you have properties of definite integration, then you have differential equations, then probability distribution, binomial distribution. So as you can see in your part 2 of 12th standard syllabus, in each and every chapter, calculus is required. All the chapters name that I said now were differentiation and integration. And to understand that part better, to understand calculus better, you need to have a solid base, and that base is your functions. So if you understand your functions well, you'll be able to grasp the upcoming chapters such as differentiation, integration in a very easy and fluent way. If you don't understand functions well, then solving questions from integration or from limits or even from differentiation would be very difficult. So this chapter is very important from your base point of view, where you'll form a base, and on that base we are going to build up your building in future, and that building is going to be your maths 2 or your entire calculus for JEE and other competitive exams. Okay, so should we start? Type in yes to let me know that you're really interested to start. Yeah, Prashant, yes, perfect. So everyone is saying yes. Okay, so here you go. Is my green screen visible to everyone? Okay. So as I said, we'll be taking a bit of different approach for functions as well. So I'll first tell you what are the different necessary functions that we need. Then we'll go in from next lecture onwards into more details of each and every functions, and we'll see few examples. We'll also see some basics of functions, what the definition is, and then we'll solve problems. So first off, I want you to think functions as a machine. And what kind of machine? Suppose you have some input over here. That input is given to your machine, and that machine performs some operations on it and gives you some output. The operations that will be performed over here in this machine are your functions. So what does that mean? Suppose I have log of function over here. So log of x is my function. If I put in some input over here, suppose I put in 2, what this machine is going to do, it will find value of log of 2 and it will print out value of log of 2 over here. If I put in 5, what this machine is going to do, it will calculate value of log of 5 and it will print out value of log 5 over here. If I put in 1, it will calculate value of log of 1, and log of 1 value is 0, so it will show value of log 1 as 0 over here. Or there can be some other machine. Suppose this machine is a square root machine, or these functions are square root functions. So what will happen if I put in 4 over here? What this machine will do, it will take square root of this term, so square root of 4, and what is square root of 4? 2. If I put in 16 over here, what I will get, this machine is going to do square root of 16, and square root of 16 I'll get output as 4. So what is function basically? Function is going to take some input, perform some operation, and give you some output. So I can say that this y is equal to a function of x, which is equal to, and over here some equation might be there, like x plus 1. So in this particular case, if I put x is equal to 1, what is going to happen to value of y? Value of y is equal to, x is equal to 1, therefore 1 plus 1 is equal to 2. Therefore, if I say that, this is my machine again, I'll draw. And this time the machine is which one? The machine is x plus 1, or the function f of x is equal to what? X plus 1. What am I putting inside this machine? I'm putting 1. What am I getting output? I am getting output as 2. Because if I put 1 over here, I'll get 1 plus 1, which is y is equal to 2. Now, if I put 3 as my input, what will happen? It will come inside this. It will check 3 plus 1. 3 plus 1 is what? 4. So I'll get output as 4. So is this idea clear? That a function works like a machine where it will take some input and it will produce some output. Now this function will have equations of different formats. It can be, like I said over here, x plus 1 is a linear equation, or it can be a logarithmic equation, or it can be a square root equation. So there are various equations or various formats of these functions. So we'll be seeing all those formats from next slide. What these machines or these functions do is they'll take some input and they will produce some output. Now, while producing these outputs, there will be some constraints, like what inputs are allowed in this machine and what outputs can this machine produce. So sometimes it's possible that you cannot put any value that you want inside. For example, consider this root of x. I cannot put in negative values over here as my input. Why? Because then it would be under root of -1, and I am checking only for real numbers. I am not checking for imaginary numbers. So my machine doesn't work for imaginary numbers. So it will be under root of -1, and my machine will say there's an error. I can't find value of this term. I can only find values of x which are greater than equal to 0. So in this particular case, there is some condition or constraint to which values can I put inside this machine. Root x. So what are the values that I can put inside? I can put only those values which are greater than equal to 0. So those values of x which you can put inside the machine or which will be your input, those values are called as your domain. So what is domain? Domain is the values of x which you can put inside that machine. And what is domain of this square root term? I can say that domain is equal to all values I can write which are what? From 0 to infinity. I cannot write any value which is less than 0. And then we have second part, which is our output. So what output will I get? Under root of 4 is 2, under root 16 is 4. If you find under root of 3, you'll get value 1.73. So you'll get all under root values as well. Under root 2 would be 1.414. And similarly, you'll get all the under root values. But can you get a negative value as output? No, you'll get only positive values as output. What would be value of under root 0? Is under root 0 a valid term? Yes, under root 0 is a valid term whose output is equal to how much? 0. So if I put in 0 inside this machine, what will I get? I'll get 0 as my output. So what are my output values from this machine? I can say that my output values are from 0 till infinity. Therefore, these output values are called as range. And range of this particular machine is from where? It is from 0 to infinity. So what is domain? Domain is what values you can put inside this machine so that the function will perform on it. The machine shouldn't give me error that if I put in -4, the under root machine is going to say, no, I cannot find value of this term. There is a problem. You should put some valid inputs. So domain is all your valid inputs which you can put in. And what is range? Range is all the valid outputs that you are going to get. Okay. So if we consider this term, y is equal to x plus 1 machine. Now in this machine, I can say that my domain is what? All real numbers, or my domain is from -infinity to +infinity. Why? Because I can write any value of x. I can write 0, I can write -1, I can write -1000, I can write 1 lakh. any value of x is possible, because all the values are valid. For none of the values I'm going to get an error. Like for if I put x is equal to -1000, this machine won't say, x plus 1 machine won't say that it's a wrong input. So all the values are valid. Therefore, my domain is equal to all real numbers. And what would be my range? What is the output that I can get when I'm going to put all these input values? So if I put in 1 over here, I'll get answer as 2. If I put 0, I'll get answer as 1. If I put -1000, I'll get answer as -99999. So again, as my output, I can get all the possible answers which are present, all the real numbers which are present. Therefore, I can say that my range is also equal to all the real numbers, or all the numbers which are from -infinity to +infinity. Okay, so log function, we'll see this in the next slide. Notice the brackets that I'm drawing. We have seen these brackets in assets and relations chapter. Which bracket have I used over here? Round bracket. Which bracket have I used over here? Square bracket this side, this bracket it's round bracket. These brackets are, this side I have used square bracket and this side it is round bracket. So what does each and every bracket mean? It has a different meaning. I hope you remember. So those people who are new, we have studied this in intervals. Open interval means round brackets. Closed interval means square brackets. And semi-open or semi-closed, as the name suggests, there will be one side open and other side closed. Now, what is open interval? It means all the points between those 2 points are included, but not the extreme 2 points. So if I say open interval from 2 to 5, so this is your number line 0, 1, 2, 3, 4, 5, 6. So open intervals from 2 to 5. I will draw a white ball over here. I'll draw a white ball over here, and I'll dark this, which means all the points which are between 2 and 5. So I can include the point 2.001 and I can include the point 4.999. But the points 2 and 5 should not be included. And if I'm saying closed bracket 2 to 5, that is written in square brackets, it would mean 0, 1, 2, 3, 4, 5, 6. That I'm going to draw dark balls over here, not white balls. And then paint all the numbers which are between them. So this would mean that all the points between, 2 and 5, because I'm starting from here. So not from this, from here. All the points between 2 and 5. And I've drawn a dark ball over here. So that means my points 2 and 5 are also included in that range. So if you want more details on this, attend the lectures on sets, relations, and functions and get more information. I'll move to next slide and we'll start with functions. Okay, I'll give you 10 seconds to revise this. If you have any doubts, you can ask. If you have any doubts, or I'll continue with various types of functions. Type in yes if you have understood. Type in your doubts if you have not understood any points. Okay, what is f of x? We'll see that f of x is your function. And right now I've said that function is like a machine, that it operates like a machine. More details of function, exact definitions, we'll go into that in our next lecture. So currently I'm taking a different approach. Instead of going by traditional definition and then explanation, I'm explaining functions as machines so that it's easy to understand. So does that answer your question, Prashant? Okay, perfect. Thanks. Others, any doubts? Rutu and Aditya saying no doubts and understood. a few more responses so that I can proceed next. Okay, let's move on. Perfect. So first is a constant function. So what is a constant function? It can be any constant term. So as I said, like function is going to be like a machine. So if I put 2 in your machine and it's just going to produce the same output, so what I will get as output is also equal to how much? 2. So in this particular case, function is equal to y, which is equal to, so this is 1, this is 2. Therefore I can say that a constant function is going to be a line which is always going to give me 2. So there is no x value present in this one. So what this machine does is it always produces a constant output of 2. It is not going to take any input. It is always producing an output of 2. So my y is equal to how much? Y is equal to 2. Okay, so what would be range of this term? Range is going to be equal to all the values of output that are possible. So which output values are possible? Only one output value is possible, which is 2. So range is equal to how much? Range is equal to 2. If I consider another function like f of x is equal to 5, I will get only one answer as output always. Y is equal to 5. Y is nothing but your output, which is equal to f of x, which is your range in this particular case. Next is an identity function. So from here, your actual important functions are there. What is identity function? Consider this one. Y is equal to x. Everyone knows the number line, right? I'm not going to explain. So this is just your x-axis. This is going to be your y-axis. This is going to be negative side of x-axis. So only in this diagram I'm writing the numbers. From next diagram I won't write the numbers. I'm going to assume that you know x-axis and y-axis. So this is passing through origin. So in this particular case, suppose y is equal to, or y is nothing but my function f of x. I'm getting an output. So consider this machine. Where function output is this. So what this machine is doing is whatever input is coming, it is giving it as output. So I'm putting in 1 over here, and what my output is y is equal to x. So my output is also 1. Okay, let's see. So if x is equal to 1, what value of y I'm getting? 1. If I'm putting in as 0, what output I'm getting? 0. So x is equal to 0, y is equal to 0. Graph will look like this. If I put in 2 over here, what output I'll get? I'll get 2. So if x is equal to, y is equal to also 2. And if x is equal to -1, y is equal to -1. Therefore, I'm getting a line which is equal to this. Therefore, my function in this case, or what this machine is doing is, it is taking one input, and whatever input is there, y is equal to x. So it is producing the same output. It is not doing any other change. Graph will look like this. It is passing through origin. What would be domain and range of this one? What is domain? Which values can I put inside? I can put 0, I can put in minus, I can put plus values also. So my domain is equal to all the real values, or I can say all the values between -infinity to +infinity. I have drawn round brackets because infinity points, you don't know which point is exactly infinity point. So round bracket means all the points between -infinity to infinity. And then you want range as well. So range is also equal to what are the outputs that are possible. So obviously you can get any answer. So range is going to be any real number, or I can say all the values between -infinity to +infinity. So I want you to copy these down as I'm going forward, because these are going to be very, very, very important to understand even your next chapter of limits and continuity. You are going to need these graphs in other chapters. So copy down. You want to take a snapshot, take it. Okay. Should I move forward? You have 10 seconds. Okay, so time's up. Next, we'll see power functions. So power functions are y is equal to f of x, which is equal to x raised to some power. That power, let us say this power is equal to n. So what can that power be? That power can be 1, 2, 3, 4, 100,000. We have already seen for x raised to 1 in our previous example, y is equal to x. So that means it was x raised to 1. And how do we get a line for y is equal to x? A straight line. And even in this example, what would be value of minus x? So it will be a line which is in this direction, passing through origin in this. Or what would be value of 2x? So only a slope will be more stronger. So this line would be y is equal to 2x. If I say y is equal to 5x, the slope will keep on increasing. So it will be more and more steep. Or if I say y is equal to half x, slope will be like this. So you can draw all the lines of y is equal to x. And remember that all the lines of y is equal to x, 2x, 3x, 5x, 1000x, minus 0.5x, all these lines will pass through origin. Because when you put x is equal to 0, you are getting y also as 0. And if you consider lines such as y is equal to x plus 1, so if you put x is equal to 0 in that case, you will get a line which is passing through y is equal to 1. So y is equal to x line is this. So y is equal to x plus line would be a line parallel to this. So just a layer above. So y is equal to x plus 1 line would be this. X plus y is equal to x plus 2 line would be like this. Okay, so we can go in more and more details, but we'll avoid that. Just erase this. Okay. So let us increase the power now. Instead of y is equal to x or x raised to 1 terms, we'll see square functions. So let us draw a graph for y is equal to x square. So what is power of x now? It is 2. Now, when y is equal to x, or I can say for linear terms, I'm always going to get my graphs as straight lines. What is the equation of straight line? X plus by plus c is equal to 0. All the higher powers are 1. But whenever this power is going to be of 2, y is equal to x square. So you're not going to get a square, a straight line. What you're going to get is curved lines. For example, equation of your circle, x square plus y square is equal to r square. So equation of circle, you are not having a straight line. It's going to be a circular ring. So whenever square term is there, remember that you will never get a straight line. What you are going to get is circumference or curved lines. Okay, so let's draw this figure, y is equal to x square. If x is equal to 0, y value is also 0. Perfect. If x is equal to 1, y value is equal to how much? 1 square, that is also 1. Okay. If x is equal to 2, what is y value? Y value is equal to 1, 2, 3, and 4. Y value is equal to 4. So graph will look somewhat like this. When x is equal to 3, it will go to 9. If it is in left hand side, similarly in right hand side, it will go like this. So graph of y is equal to x square looks like this, and this is nothing but your parabola. Now there are few points to remember in this. Can I take value of x as negative? Yes, I can take x is equal to -1. If I put x is equal to -1, what will be value of y? What is -1 square? It is +1. So even if I take x is equal to -1, I'm getting a positive value of -1. And even if I take x is equal to -2, I'm getting y is equal to how much? 4, a positive value. X is equal to -3, I'm getting a positive value. So my domain, or what values can I put in the machine? What are the values, valid values? For x, I can put in anything. I can put in 0, I can put in positive values, or I can put in negative values. So my domain is all my real numbers, or I can say from -infinity to infinity. However, my range, that is my output. My output is never becoming negative. When x is 0, I'm getting 0. When x is 1, I'm getting 1. But when x is -1, I'm still getting 1. Is there anything negative? There is nothing negative. My answer is always positive. So I can say that my range is, or my outputs will be from 0 to infinity, not from -infinity, because my answers or my outputs, this machine y is equal to x square, my square machine will always produce positive outputs. Which bracket should I use over here? Round bracket, because there's infinity. Whenever there is -infinity, infinity, you should always use a round bracket, because you cannot include those points. And which bracket should I use over here? I will use my square bracket. Why square bracket? Because 0 point is included. If x is equal to 0, y is also equal to 0. So can I get my output as 0? Yes, I can get my output as 0. Hence, my range is going to be equal to from 0 up till infinity. Okay, so this was square. What about cube? How would my cube value look? So again, let's try to draw. If x is equal to 0, y is also equal to 0. Okay, if x is equal to 1, y is also equal to 1. If x is equal to -1, y is equal to how much? Y is also equal to -1 point. If x is equal to 2, y would be equal to how much? Y would be equal to 8, 2 cube. So which diagram are we solving for now? We are checking for cube relation. So if x is equal to 2, my input is 2, then my function, what it is going to do? My machine is cube machine, so it will do cube of that. And what is 2 cube? 2 cube is 8. So if I put x equal to 2, I'm getting my output as 8. Similarly, if I put x equal to -2, I'll get my answer as -8. If I put -3, I'll get my output as -27. If I put 3, I'll get my output as +27. So if I draw a graph of all those values, the graph will look like this. It is passing through 0, but it can take all the values in both directions, in positive as well as negative. So what is my domain, or what values of x can I put in? I can put in positive values of x or negative values of x. So my domain is all my real numbers, or I can say all numbers from -infinity to infinity. And my range is equal to what? My range is also going to be all my real numbers, or from -infinity to infinity, because what is value of y? It is going in both quadrants, positive quadrant and negative side also. So value of y is also equal to both ways, positive and negative. Also remember that y is equal to x cube. So all your cube function graphs like x raised to 5, x raised to 7, all these graphs will look similar. There will be difference in slope, but the graphs will be same. So all your cube function or x raised to odd power functions, x raised to 5, x raised to 7, x raised to 9, will be having this domain and this range. Obviously not applicable for x raised to 1, because we have already seen x raised to 1 is a linear function which passes through x is equal to 0, and it's a straight line. Okay. Also remember that if in this particular case I had considered my origin as vertex point for my parabola, if I consider or shift my parabola to other point, my origin will be shifted accordingly, and according to that vertex my range can change. So as I said earlier, we'll just go first through an overview and then get into more and more details as we understand the basic terms. So from this, I just want you to get familiar with graphs, to get familiar with how to find out a domain value, how to find a range value, how you can solve or how you can understand the basics of graphs, like how the graph is flowing. So I just want you to focus on these parts first. Actual solving, we'll do it later on once you have get these basics done. Okay, so should I move to next slide? You have 10 seconds for this. Next, we'll see polynomial functions. So again, in this you can find out linear that I've already talked about, or there can be quadratic equations that you want to solve. Linear equations, remember, you'll always get straight lines. Quadratic equations, remember, there will be always curved lines. So linear equations, take any equation. So consider y is equal to 2x plus 2. You can consider any line like 2x minus 3. Any line would be perfect, no problem. So let's draw a diagram for this. X is equal to 0. If I put x is equal to 0, what will be value of y? So what is my function doing over here? My function is performing this operation, 2x plus 2. So if I, in this machine, I am putting x is equal to 0, what my machine will do, it will do 2x plus 2 and produce some output. That output is my y. So what output I will get if x is equal to 0, 2 into 0, 0 plus 2, that is 2. So when x is equal to 0, I am getting value of y is equal to 2. So this point. Okay, I'll put x is equal to 1. So what value of y will I get? X is equal to 1, therefore y is equal to how much? 2 into 1, 2, 2 plus 2, 4. So 3, and here I have 4. So when x is equal to 1, y is equal to 4, this point. So my line is going to be like this. If I put x is equal to, this is minus 1 and this is suppose minus 2. No. So this point would be how much? Yeah, this point is minus 1, this is minus 2, minus 3, and this will go on continue, x-axis, y-axis. Okay, so if I put x is equal to minus 1, what would be value of y? X equal to minus 1, that would be 2 into minus 1, minus 2 plus 2, 0. So when x is equal to minus 1, y value is 0, so it will meet at this point. If x is equal to minus 2, value of y should be minus 2 into 2, that is minus 4 plus 2, that is minus 2. So minus 1, minus 2, this point. When x is equal to minus 2, value of y I am getting as minus 2. And similarly, all the points will satisfy. So if I write my domain, what is my domain? All my real numbers. What values can I put in place of x? Any value. I can put 0, positive values or negative values. Just that it should be all real numbers. And what is going to be my range? My range is also all the values I can get. My straight line is positive axis, negative, 0. All numbers are possible. Therefore, my range is also all real numbers. Now let us see for quadratic equations. So quadratic equations can be x square plus bx plus c format. Therefore, if I draw, we have already seen one quadratic equation, y is equal to x square. So how was graph of y is equal to x square? It was like this. So depending on your equation, your graph will move to suppose this point if your vertex is shifted to some other point. If my vertex is h comma k, where h is my x-intercept and k is new intercept, then equation of this graph, I can say it is y is equal to x square plus bx plus c. If my h and k is moving to some other point, my graph can also look somewhat like this. So it depends on which equation it is. So if I say x square plus 4, that graph will shift to my left hand side. If I'm saying x square minus 4, that graph will shift to my right hand side. Or that graph can shift upon my x-axis and below my x-axis, depending on which equation I'm writing. As we have seen for this, depending on which linear equation I'm writing, my line graphs will either move towards left side, right side, or the slope will keep on changing. The only point to remember is that the vertex is there. The output is always going to be those values which are greater than this vertex point. So y is equal to x square. For that function, we have seen that my range was always from 0 to infinity. Because at that point, my 0, 0 was my vertex. But instead of 0, 0, if h and k is my vertex, then I will get all the values which are greater than this vertex point. So my domain for quadratic equations, it can be any real number. However, my range is going to be, if my vertex is hk, so obviously it should be greater than that my vertex point. So that is going to be range is equal to k to infinity. And you can also find this vertex point. H value is minus b by 2a, and k value is b square minus 4ac by 4a. I hope you have remembered these. Like after solving the quadratic equation, you get your h and k vertices. This was solved in 8th, 9th, 10th standard, I think. So your h and k values would be this minus b by 2a and b square minus 4ac by 4a. Okay, so we'll stop over here. There are many other graphs, like log graph is there, then greatest integer function graph is there, mod graphs are there, rational function graphs are there. So first we'll go through all the graphs and then we'll start with problems. Okay, so as time is up, we'll stop over here. We'll follow our regular drill. Let me know in the chat box if you have understood, enjoyed the lecture. If you have doubts, let me know. If you understood 80% lecture, type in 80%. If you want something more from my side, type in to let me know. Okay, so thank you from Prashant, understood from Aditya, Om, Melvin, enjoyed from Melvin. Pranika is saying all clear. Path is saying 85% as understood. Yes, because it's getting more technical, you can say. It's interesting though. Muzamil and Asta are saying understood and enjoyed. Do practice at home. I hope that you have taken snapshots and notes, because you are going to need them as we are going to proceed. So next lecture, if you're not sitting with notes at your home, do take pen, pencil, paper, so that whichever graph I'm drawing, you draw with me parallelly and you'll get a better understanding of that. Okay, Rishikesh and Yogita, I have saying understood. Okay, bye. Thank you, everyone. I'll end the lecture. Thank you. Okay, have a nice day, everyone.